Hello everybody and welcome back. We're going to continue looking at the Gauss paper from the year 2001, and that's the grade 7 Gauss paper, not the grade 8. You'll have to look elsewhere on my channel for the grade 8 Gauss from 2001. We're up to question number 19. Hopefully you've had a chance to take a look at it. So question 19. Rectangular tiles, which measure 6 by 4, are arranged without overlapping to create a square. The minimum number of these tiles needed to make a square is... Okay. So this is a bit of a challenge here. So, we're trying to make a square, and what do we know about squares? Well, squares have the same length as they do width. Okay? And if we know the length, then we know the width, and once we do that, if we multiply them together, we have the area. Well, I know my rectangular tiles measure 6 by 4. That's the information I'm given. I'm given the length and width of my rectangular tiles, so I know the area of my tiles. And if I'm creating a square, once I pick a name for the side length, I will know exactly what the area of the square is. So each tile has area 6 times 4, 24. We're not given meters or anything, that's okay. It really is. But we know each tile has area 24. Now we don't know how many tiles we have, so we'll give it a name X. So X tiles make a square of side length Y. Then X times 24, because each tile has area of 24, is going to be equal to Y squared. Okay. Now, we're looking for my pen seems to have died for just a second. We're looking for the smallest square. So we want the smallest y so that y squared is equal to 24x. Now 24 is a whole number, x is a whole number, so y squared is definitely going to be a whole number. So we have to start thinking, well, what squares are divisible by 24? Okay. 24 is 2 times 2 times 2 times 3. Or using exponents, we could write 2 to the power of 3, 3 to the power of 1. Okay. Now we want, we know that y squared is going to have 24 as a factor. So, what do we want to say? So we can see that 3 divides y squared, which is just y times y. And since 3 is a prime, we know then that 3 divides y. Okay. In the same way, we know that 2 to the 2 squared, well, actually 2 to the 3 divides y squared. So we need to split up 3 factors of 2 amongst 2 y's. Well, we're going to get, maybe 1 y over here and 2 y's over, or sorry, not 1 y over there. 1 2 over here and 2 2's over here. We're going to have at least 2 squared divides y. So at least 3 and 4, so at least 12 divides y. Let's try y equals 12. Because that's the absolute minimum. This might not work. Maybe we'll have to go to the next multiple of 12. But we know, just by looking at it and knowing that 24 has this prime factorization and 24 is a factor of y squared, we know we will have y is a multiple of 12. So the smallest possible multiple of 12 is just y equals 12. This might work. It might not. If it doesn't, we'll have to keep going on to the next multiple and the next multiple until we find that it works. So y squared is 12 squared, which is 144, which is 24 times 6. So we think x is equal to 6. And if you wanted to stop there, I wouldn't fault you. It's the grade 7 paper, so we're not looking for rigorous answers. So let's see, 6, that's E, that's way over here. Okay? So I really wouldn't blame you if that's what you wanted to do. You wanted to say E, okay, we're done. But if you want to make absolute sure, then I would take 6 tiles and arrange 6 of these 4 by 6 tiles and arrange them to make a 12 by 12 square. And it doesn't take that long to think of this arrangement right here, which is 4, 4, 4, 6, 6. So both side lengths are 12, and we have 1, 2, 3, 4, 5, x equals 6 of these tiles. So not only does it work just out with the mathematics and we get 6 tiles, but we actually know that we could arrange these tiles and get ourselves a square, and that's just the extra little step to make sure that we do have the right answer and that the math does reflect the real world situation. Okay? Because, I mean, just by comparing the areas, we had an idea of what y is, but just because the areas all match up doesn't mean the tiles will actually fit together. So we take a little extra step and make sure that they do work out. And that was question 19, I believe. Yeah, question 19. So in the next video, we'll see question 20, and we'll handle that in the next video.